Hello, hey, good morning, everyone. So, I'm Nandit, and I'm the founder of Lighthouse, and I'll be giving a session on a technical overview of Filecoin, and it will be divided into two parts. One is we'll go deeper into Filecoin tech, and then the remaining half I'll share about what we are building at Lighthouse on top of Filecoin. Cool. So yeah, Filecoin is the largest decentralized storage network. It has thousands of storage providers committing storage capacity to it. Um, like tens of nations, like 40 plus nations represented, and a lot of economic value committed to it, like over 170 million of pledged Filecoin. And yeah, the network is pretty huge at the moment. As of November, the total storage power was over 9 exabytes, over like 3,000 storage providers. Um, like one of the key Web3 use cases is around NFTs. So it had over 100 million NFT files being stored and the daily onboarding rate being over 5 petabytes, which is pretty huge, I would say. And then, yeah, how I see it is like IPFS as a peer-to-peer network was missing an incentivized layer. Like, how do you pay folks over a peer-to-peer network to keep your data over time? So Filecoin is that missing incentivized layer where I can now pay a miner in Filecoin tokens, get a stronger guarantees that, yes, they will be keeping my data. And at the moment, the network has evolved that right now it's not just storage, but there are other tools like Saturn building retrieval things, and you can compute over state using FVM. And then there are teams like Bucklehow doing like compute over data itself. And the key benefits of Filecoin would be that it's compatible with other Web3 protocols. Let's say if I meant my data on some other chain like Ethereum, Solana, I can store my data easily on Filecoin with Web3 primitives. It provides me verifiable data with cryptographic proofs. And it's massive size, like it's, I would say, enterprise ready as well. And some of the miners have been able to like have a setup within their basements as well. But we have seen like some very sophisticated miners putting like big storage capacity. Like the one I visited last year was in Vegas. And then there are other folks in Singapore. And there's this another great miner from Decent that we're also storing a good amount of data with based in Amsterdam. And then, yeah, how does a Filecoin storage deal looks like? So essentially, a client um, pays storage providers to store data, and that could be through a node. And then it's like a contract, which is like a 6 months to 1.5 years contract that, okay, I'm storing my data with you. And then when the miner gets the data, the first part is proof of replication, which is this proof that, okay, this is a unique physical copy of your data, and I'm not imitating like a fake copy. So it's like the first proof that the miner gives when they onboard your data. And then more importantly, there's this proof of SpaceTime, which miners provide every 24 hours that, yes, I'm keeping your data. And if they miss a proof of SpaceTime, then there's a penalty from the network. So there's a strong incentive for them to keep serving your data. And at the end of what we call as a storage deal, that would be like a 6 months time period. A client might want to either renew it or let it expire if as per like their need. And yeah, like this is a dashboard of Phil Fox where you can see a lot of deal IDs, which is like commitment between a client and a miner that I'm sharing my data with you. This is the time it was created in. This is the size of the piece, like the size of the data. And then I can like click on one of these deal IDs and get further information on is this a verified deal, which means like a miner has some further block rewards because it's a quality data for the network. And yeah, talking a bit about the algorithms, Filecoin has this consensus of probabilistic BFT. The proofs involved proof of replication in space-time. And there's this another proof that I'll talk about later on that we at Lighthouse implemented where we can prove that, okay, your smaller, maybe 10 MB file is in a 32 GB bundle. We call it pod side. And then the verification is through like these ZK snarks. I would say like, in short, like these proofs are pretty large and ZK snarks make them like small enough that all the miners on the network can store them. So I would say like that's a very sophisticated technology. And then networking goes through like the P2P and then built on other crypto native primitives. And then you're talking about Filecoin virtual machine. We had this like base layer which provides an onboard storage capacity from some time, but now last year in March, Filecoin virtual machine came live, which essentially I see it as a way like I can, as a developer, write Ethereum like maybe Solidity contracts now on top of Filecoin, interact with the base storage layer, and then build some cool dApps. And it's quite interesting because now it opens that economy where previously, if I was an Ethereum developer, I can build things on Optimism, Arbitrum, but now I can also build cool new products on top of Filecoin virtual machine. And I guess most of the Web3 developers are building in Solidity. So it's like super beneficial for new kind of applications to bootstrap. And then essentially, FVM is like a runtime environment to write smart contracts. It's WASM based, but then the FEVM part of it is Solidity compatible, like Ethereum like a chain that you can build applications like DataDAOs, Perpetual storage that we are working on, and then some interesting DeFi products like Glyph team, who have like recently amassed like I guess 200 million in TVL, which is amazing. And essentially, like through libraries like Sondex now on VS writing Solidity contracts, I can fetch data back and forth from the base storage layer. Yeah, that's about Filecoin, and I'll now add about what we're building at Lighthouse, but I'm happy to take one or two questions before I move to that, if any. Yep.
Just can you mentioned the expected consensus that you mentioned before that you mentioned the sort of consensus mechanism. I know this can get very, very hairy if one goes into the details, but can you maybe give like a 1 minute sort of summary of how does actually the network sort of digest the proof of spacetime and the proof of replication? So I'm a storage client. I guess I post some data on IPFS through my Lotus client. I have some Filecoin. I try to broker a deal. I guess at some point someone accepts that deal. There's a deal ID that's issued. Now the storage provider sort of has signed and is posting this proof of replication. And then after every 24 hours, it needs to have this proof of spacetime. But where does that proof go? Who decides whether there was a violation of the deal? Sort of, maybe like a 1 minute. I don't know whether that's possible.
I can add some of the things that I know about it, and then it's a very, I would say, technical topic, so might be even outside my expertise. But when we're building Lighthouse, we see that miners, they randomly prove some parts of the data that they are storing, and then we get this information from the network that they are actively proving these sectors. And like since it's random sectors, so it's I guess helpful that I need not prove every sector because I have like a lot of data as a miner. So if I get to randomly prove these sectors, then in a way, like it's expected that I will be keeping proofs for other sectors as well. And then we get this information that, okay, miner is actively proving this, then that's more than enough for us to know. Then what we do at Lighthouse is we check after 24 hours if a miner is not proving. On our interface at the moment, we give that, okay, the POSG is live or not. So I'm not sure how would somebody get like a fail-safe on if a miner didn't give a proof of space-time. Maybe other miners can check for it and then share that, okay, you're not proving, so you are slashed some rewards.
Yeah, so the proof, the PO-rep, I believe, lands on chain. There's two different types of PO-rep messages, and these are by far the things that are like landing on chain the most in the Filecoin network, so the most common messages. So there's like a proof commit 1, proof commit 2 message types, and those go on chain and have a time gap between them. There's actually this new thing called non-interactive PO-rep that would simplify it down to just 1. So if you're interested in that, happy to talk to storage providers about it. But it's larger and more computationally intensive to compute, but you only have to do it once and you don't have to store data in between. So there's a potential improvement there. Proof of space-time, we actually took off-chain during, over time. It started out as it was also an on-chain message. And this was the one where it's like, great, you're sampling a whole set of different pieces within your sector, and you have effectively a window where you have to post, or previously you posted it on chain, and you were, using a ZK Snark to compress all of those tiny proofs into a small message that would land on chain. What we just found was the amount of scale that was happening when Filecoin was going from 100 petabytes to 10 exabytes of storage was okay, this is too many post messages. We're on a trajectory where the Filecoin network will not be able to keep up. And so that was brought off chain, and there's now a thing that a number of storage providers and network participants run called a disputer, where it is looking for those storage or those proofs of space-time that are published to the network, but are not put on chain. So it's a message, and you're looking at those and you're checking, are they valid? And if they aren't valid, if your disputer catches a problem, then you get a bounty by posting that on chain. So only the ones that are not valid are the ones that actually get posted on chain. So it's a scalability improvement. And I think that was done in I don't remember which FIP, but I think it must have been winter of 2021-ish, winter, spring, where that it was called optimistic proof of space-time or optimistic post. And so they're expected to be good until proven on chain, fraudulent, and then both the reporter gets a bonus, and that's why people are willing to spend the energy to run the disputer. So
it's effectively an optimistic roll-up in a sense that only when someone disputes that.
Yeah, it's the same optimistic process.
Yes. And then the whole sort of slashing kicks in. Okay.
Yeah, and slashing, slashing the first window post that you miss, you don't actually get slashed, because we're sometimes you get a grace period. This was also done in the early days of I think just pre-mainnet, where we realized sometimes something goes weird and you miss your window. And so it's only on the second consecutive slashing event where you get a pretty large and increasing penalty. And every day that you miss it after that, your penalty increases and increases and increases. But you do lose power the first time that you miss one of these. And so you lose the ability to win any additional block rewards from the network until, and this is for any sector, if you have hundreds and hundreds and hundreds of sectors, each sector is 32 gigabytes. If any of them fails, you lose the ability to win rewards from any of your other sectors until you recover that sector and you prove back to the network, no, it's actually good. I promise I'm still storing everyone's data. Yep.
How common are they?
I think the question was, how common are the slashing events? There is a dashboard called Starboard that lets you look at all of those events. I think we tend to call them faults. Disputers are very uncommon. So it's much more common that people will miss a window post epoch than submit a bad window post proof, because that takes effort. It's much more common that you're oh, my internet went down and I missed my proving window. And so those are what are called faults. And there's faults and then there's penalties. And you can see all of those in the kind of capacity dashboards on Starboard, starboard.dashboard. something.
I think there's also another filrep.io where you can see miner, how active they are. So many have 100 by 100 ran there, but some have 98, 99. So filrep.io is another to check miner reputation.
If you're, you have the data, you want to store it with a storage provider, you want it to be open or you want it to be private. Is that something you can decide with the storage provider upon the moment of the deal?
Yeah, I think essentially, from my understanding, Filecoin doesn't provide an encryption layer. So either you can encrypt on your own and store private keys with you for that, encryption keys with you. Or I think you can also talk to the miners that maybe just let me retrieve it, doesn't let don't let anyone else retrieve my deals. So that is also a component there.
And then I guess if it's done incorrectly, is there a slash issue there? Is it, or it's just always
right now.
okay.
Interestingly, if you have like large enough data, some miners even are interested to sign like a SLA as well. So that could be interesting. But yeah, those are taken off chain.
Okay, thank you. This is a common question people ask me when I'm talking to more Web 2 facing people. They're like, what if I don't want everyone to have my photos or whatnot? So I could say, you could encrypt that before you make the deal with the storage provider. And that's correct.
We'll do that for you. And you can also use the gravity, which will, once the storage providers take that back and allow less people to make it.
Cool. I guess I'll move to the Lighthouse part of it on how we are building on top of Filecoin. So we're essentially building permanent on-chain storage and super excited about that. So yeah, like my team, we've been contributing to the Filecoin ecosystem in some way or the another from last 3 years and making it now super easy for developers to build on Filecoin and leverage the powers of Filecoin virtual machine and solving major pain points for developers. So I guess my journey as well in the ecosystem was through an hackathon and then later on joined a portfolio company of Filecoin ecosystem, Fleek, and then got a grant from Protocol Labs to build an open source project. Then went through a Filecoin accelerator with Longash Ventures based out of Singapore. Then raised some money from like crypto VCs. So I would say I've read the whole Filecoin pipeline, which is quite interesting for me. So yeah, super excited to share my experience around that if anyone is curious after this talk. Yeah, so something that we've built after this FVM came live last year is what we call as programmable storage that we enable through our SDK. So in a way, it means that you can program a resource like storage on a granular level. And essentially, I see it like it makes storage much, much smarter and something traditional cloud doesn't provide. That on a traditional cloud, you can just upload your data. But now using the power of FVM via our SDK, you can configure how many replications do you want? How does the file renew with the miners? What happens if a miner drops the file? How does a repair process works? And which miners do you want to store your data on with which locations? So when we were building like our permanent storage model, previously we were planning to have a different kind of architecture to power that. But when FVM came live, we built up this SDK along with discussions of some spec with the FVM team. And we realized like this is much superior architecture to enable our permanent storage model and can be relevant for other teams to build cool, interesting new applications on top of FVM, ranging from, let's say again, perpetual storage that we are building right now. It could be like something around programmable access control. People can build like some interesting like insurance markets on top of FVM using like our FVM programmability work. Yeah, so the first application that we are working ourselves, we call it like as perpetual storage contracts. So how it is powered by is like we have a on-chain, a smart contract based endowment pool, which pays for ongoing renewal of your files. So as a user, you pay upfront for your storage deal, and like a portion of it goes to the miner for deal making, and the remaining portion lies in this endowment pool, which can further be put into protocols like Glyph to increase the endowment pool like any real world university endowment works, and then fund ongoing storage or deals of a file. So I guess the initial idea of it again came from another protocol out there in the market, which is Arweave offering permanent storage. But we realized that IPFS and Filecoin is adopted more widely and has a bigger ecosystem. So if we build this proposition natively for Web3 applications on top of Filecoin, it's a much bigger market. And at the current state of it, it's like already live on mainnet for our internal testing. So we are now aiming to get an audit by the coming month from a couple of audit firms. And then in May, it will be live in production for developers to use in their applications. And then to highlight some of the use cases of what people are building on top of Lighthouse using this is there's this application called as SP and DAO, who build like a credit score of data DAO, and they're using Lighthouse to store their data permanently. And also they have this pool encryption features as well, because users contribute their credit score data, and then if in future they monetize in some way, then all the SP and DAO members can be rewarded. Another integration that is live with Lighthouse is with Ocean Protocol, who is like now making strides in decentralized AI space. And now if you're a developer on top of Ocean, you get there an option directly to store data on Filecoin using Lighthouse, which I think is pretty cool. Then we worked with another project which is called as Rolex, who are storing their proof of data availability on Lighthouse and saving good cost over the likes of optimism. So I think that is super cool, and now trying to work with other DA layers as well for a very native integration where Lighthouse can be used as a long-term storage option when they prove the DA proofs on maybe execution chain or any other chain. And then the new DA nodes can also index and refer to data which is stored on Lighthouse when they are spinning up. And another application definitely is around NFTs. We see various white labeled NFT marketplaces. And recently we're also onboarding NFT storage to Lighthouse as well, was spending their permanent storage endowment pool, and they have most of the top users like OpenSea, Rarible, Magic Eden, etc. So I think NFTs as a vertical is super cool, but then we have also been contributing to others like DA and then decentralized AI and maybe future ZK proofs as well. So when I say on-chain deals, what happens is with Lighthouse, you can upload a CID on-chain on our deal contract, which is deployed on FVM. And then we have this backend piece of code that we call as RAS worker, which listens for the data that you pushed on our contract, pulls it either from like a staging layer that could be our IPFS node, or that could be a public available data source. And then depending on the configuration that you asked, like, let's say 3 replications for next 2 years on this particular set of miners, we initiate deals through our deal engine with various storage providers. And then after that, we give like this on-chain proof called as PODSI. So initially when you upload the file, it goes to our aggregate node, and then this proof is stored in a DB, and which we give it back through a PODSI API. But the interesting part of that is, even though we are giving you the proof via an off-chain maybe API, but you can verify it on-chain yourself on Filecoin virtual machine. So I think it's more than enough for you to, as a guarantee that your 10 MB file is in a 32 GB Filecoin sector. So super useful for at least Web3 applications to start off that have like maybe a lot of millions of KBs or MB size files. And then, yeah, this is another thing that our team built, and we made it open source as well. We call it Programmable Access Control. How it is run is we have these multiple Lighthouse nodes. So you can come to Lighthouse and say that, okay, I want to store an encrypted file. There's a process of distributed random key generation. And after that, the decryption key of your file is split across 5 different Lighthouse nodes. And whenever next time you come and you're like, okay, I want my encrypted file back, you sign from your, it could be like a MetaMask wallet, it could be Solana wallet, it could be even, let's say, your Google GitHub auth. And then that signature goes to all of these 5 Lighthouse nodes, and we use like 3 or 5 threshold cryptography. So if 3 nodes out of 5 says that, yes, this signature belongs to the right user who is the owner of this file, then we share the, those nodes share their key shards back to the user, and it's aggregated on the client's end, and then they can decrypt the file. And we also support passkey signature here. So that means that for developers, they can use libraries like WebAuthn for fingerprint and Face ID login, and maybe implement that in their application. And we will authenticate your passkey signatures, and then you can decrypt your file. And we saw some people building some interesting applications. Let's say there was this one where if you own one Pudgy Penguin on Ethereum chain, you can just pass this parameter that I want only Pudgy Penguin owners to view this file. And then without even sharing the encryption keys to the file, if they can authenticate that they have the Pudgy in their wallet, they should be able to view the file. So I guess this is on the spectrum of UX and security. The best user experience is that, okay, I store all of your decryption keys with me, but then it comes at a security cost. Then the worst UX experiences let every user store their own decryption keys, and we see like it's not good for retail users, but then great for security. I think ours is more in the middle range where we store these keys for you, but it's not stored at one node. It's split it across 5 nodes. So I guess this is a very cool implementation. And we've seen like some open source wallets using this for their own use cases. So it's cool. Yeah, I'll just briefly touch on what's next for us at Lighthouse. I like to always discuss things and okay, what's our short-term, medium-term, and long-term priorities. So the short-term priority is definitely what I said earlier, is that get an audit for our smart contracts for endowment pool by May, and then deploy them in production. We'll initially have a Lighthouse endowment pool, like which will be storing all sort of data from like NFTs to DA to maybe even like decentralized AI and whatnot. And then there will be an NFT storage endowment pool, which the team and NFT storage will be managing on their own. They could maybe initially control it by their own and maybe future transfer it to a DAO. So as per them, and then they could potentially use it as a public good where like OpenSea can fund the endowment pool, or it could be funded by storage fees for the files. So, and at Lighthouse, like our medium-term goal is like go permissionless with Lighthouse nodes and spin up a DAO, because I think this is an important layer over Filecoin. And if this proposition of permanent storage has to stay long-term, maybe longer than our lives, then it has to be a community-wide effort where the piece of our programmable storage backend can be run by other parties as well. And then our endowment pool should not be controlled by just me or my team. It should be controlled by a DAO, possibly via our token mechanism. And then the long term, our goal is like, how do we set Lighthouse to become the default on-chain layer for Web3 projects to store data on decentralized storage? We have already started and penetrated NFTs, and then working with some DA projects as well. And then vertical by vertical going towards decentralized AI, ZK proofs, and some more use cases. So that if folks in the Web3 industry want to leverage decentralized storage, Lighthouse is the default layer that comes to their mind. Yeah, I think my closing thoughts are collaborate. Good starting point would be check out our website, lighthouse.storage. We have a cool interface there as well, which could be a good starting point. And then you can go to our documentation. So maybe try that out or give us feedback. If you're already building in the Filecoin ecosystem and if you feel like some of our tech could be useful to you, that will be amazing. If you feel some of your tech could be useful to us, that will be amazing as well. So yeah, let's collaborate and build the future for Web3. Yeah, thank you and happy to answer any further questions.